Hello everyone. Yeah, so we are going to start here. And so today our topic is like mastering sentiment analysis with LLM. Hello everyone. Yeah, so we are going to start here. And so yeah. So today we will, okay, let me give you the agenda for today. So I'll share my screen and then we can just a minute. So I will give you the agenda for today, and then our instructor Sandeep Giri will join, and he will take it from me. So let's start. Yeah. So today our topic is mastering sentiment analysis with large language model. So we have already done several times, I guess, if you are like familiar with NLP. So you may have done sentiment analysis with different techniques. But with introduction to large language models, and as we know that they are running on the peak, so now like every application is being extended to large language model. Like how we can utilize LLMs to do any of the tasks. So here is our approach to like perform sentiment analysis with large language models. So let me give you the agenda for today. So we will start with like about speakers, and then we will start with about CloudxLab. Then we will study what are LLMs, and then we will go to ChatGPT. I guess everyone today know about ChatGPT. So then we will start with taming ChatGPT and LLMs. So here we will like study how we can use LLMs for different purposes for different applications, and then we will study ways to use LLMs. So we will study what are the ways in which we can use LLM. So like we can generate text response from it, and we can also use embeddings from it. And we will use OpenAI embeddings and LLM for that. And then we will do a live hands-on on sentiment analysis, where we will start with very basic mathematical concepts such as vectors, Pythagorean theorem, and then we will go into deep into how embeddings are working, and how do they what do they represent, how to visualize them. And then we will also go through how to utilize embeddings to perform sentiment analysis. So Sandeep Giri will be our speaker for today. So he's a founder at CloudxLab, and he loves to explain technologies. He is also AI leader and software engineer, and leads like several companies and several talks and everything. He in the past he has worked upon on Amazon, in Mobi, Shaw, DevRev, and very tech, like several tech giants. And he graduated from IIT Roorkee. So yeah. So you can scan this QR code to go to his LinkedIn. So you are feel free to like ask chat your questions and doubts over chat, and YouTube chat, and for Zoom during using the Q&A window, and also you can use the chat, I guess, but more like you use Q&A window in Zoom for that. So what is our vision at CloudxLab? So our vision is to like upskill engineers and IT professionals in deep tech, deep learning, machine learning and big data technologies, making them employable and future ready. Like with current change of technology, we like build careers and improve lives. So we also have a playground for hands-on, like where you can execute a particular code, and then you can execute and then test it up through our assessment engine. So it will give you like a result. Like if your code passes the test cases, then it will like give you result that yeah, it's good. Because we believe that hands-on learning is much better than watching lectures for like 2 hours lecture or 3 hours lecture. So in hands-on learning, yeah, you can practice that concept there and then. So that's why the hands-on learning is generally preferred. So we have a playground for hands-on, and our system evaluates the code automatically and nudges the user by giving appropriate feedback. So in this case, this is the exercise. and this code passed the test case. So we like gave the feedback, good work, you have learned about string operations in Python. But in case like your code like fails a particular test case, so we guide you like yeah, your code is failing this test condition and what can be improvements and other things. We also have a console where you can practice everything. So we have a cloud-based lab with pre-installed tools and software for practicing AI, ML, DL, data science, big data, and related technologies. So, our lab consists of wide variety of tools which you can practice, including OpenAI and modern technologies also. Because our courses and labs are like updated frequently according to the industry standards. So our online cloud-based labs give you a real-world experience because lab setup is exactly same as a setup of enterprises, like how you work in industry. Our lab represents that environment only to make you industry ready. We have a central data set where we provide you lots of data sets and lots of like things to practice. But you can also upload your own data set or use open source data sets available on lab. You can connect from any browser, SSH, or through console, or through device, or any operating system in case of our cloud lab. So that's why it's very useful for everyone because you don't need a particular environment to connect. You just connect it from anywhere, and we provide you the particular environment to connect. We also have like a very playlist, and we also have a social platform where you can learn better with peers. So everyone has a user profile, so you can compete and you can like see where they are, where you are standing, and we will also give you a like graph of like what you are studying and what you have studied. And then we also have a dedicated discussion forum for your doubts, for your tech related doubts, or if you want to discuss something new. So our discussion forum is so much active. So lots of learner like comment their doubts there, and we like answer, and the learners only like answers itself. We also have a dedicated job portal where the companies post their jobs, and like you can apply through our job portal. So upgrade career and enhance salary and move job by applying to jobs posted by our hiring partners. We also conduct several exams to like test your skills on the topics you have learned. And yeah, so we will start with what are LLMs. So that's our like first topic. That what are large language models? So large language models are the state of the art AI models designed for processing and generating text. They excel in language comprehension and generation, and they possess contextual awareness. So I will like we will like do hands-on on like what all these points like represent. So in case of like state of the art AI models designed for processing and generating text, that is what they takes some input, and then their output is probably generating text. So text is also like depends on how we want it. Like it can give you vectors, it can give you embeddings, or it can give you direct text responses. So you just have to pass instructions through it, and then it will like give you like what all it produces. It also excels in like language comprehension and generation. So that's its main task for a large language model. So like we have several large language models in today's date, such as ChatGPT or Google Bard, or Meta is also developing their own LLM. But ChatGPT is the most advanced LLM till nowadays, and considering the like new OpenAI Dev Day event. So ChatGPT, like they have like promised several new features, which are like much useful for developing AI models, and that makes them much easier to develop like AI models. They also possess contextual awareness. So what is contextual awareness? Like they know the context of the thing. Like if you are saying a particular sentence, so they know in what context it is being spoken. They are trained on large data sets, granting them access to wide range of knowledge and information across various domains. And they are revolutionizing industries by several means, such as customer service, content generation, language translation, virtual assistant, and more. So this is like our like this is what a large language models are to do. The most famous LLM, which we also know, I guess most of all you would have like used LLMs for now. You must have used ChatGPT or also have explored Google Bard and like show like how it is working and how it responds. So like responses are like generally outstanding. Like before arrival of ChatGPT, like I guess 1 year back, we do not even wonder like like this accuracy in NLP would be possible in so much less time. We expected that it may take 5 or 6 years or more, but it was like literally wondering that seeing the performance of ChatGPT in our daily tasks and several other things. So, what is ChatGPT? It is an NLP model, natural language processing model, and it generates human-like responses in chatbot applications. So that's our like task for model. So our so Sandeep is ready now here, and he will like take it over from here, and he will be able to explain you better about LLMs and everything. So I will just stop sharing my screen and make him post. So just a bit a minute. So he's just joining. So just wait a minute, and he'll join. Till then, we can discuss like how LLMs have been used for useful for you. So you can like type in like how LLM was useful for you in the chat in YouTube and other things. So Sandeep have joined us. So hi Sandeep, you are on mute, Sandeep.
Sorry, guys. Yeah. Hello, everyone. Great, great. Um, thank you, Shubh, for covering while I was joining. So, yeah. So where are we right now?
So I have like gave them the little intro about CloudxLab and what it does, and I have started LLMs like in the slides in the presentation. So you can take it over from here and explain LLMs in your own fun way, so they can understand better and enjoy working with LLMs.
Just give me a moment. Wonderful, wonderful. And to which slide are you on?
Uh, you can start from LLMs itself. I have not covered much. So LLM ChatGPT 17 slide.
Hmm?
LLM ChatGPT 17 slide.
All right, great, great. So wonderful. And I'm super glad to see so many people signing up for this. And I think this is going to be probably the most important thing that you'll learn about the large language model. When we talk about large language model, people think that okay, everything is ChatGPT. It only answers questions. So one of the one of the questions that I usually ask is that if you have, let's say, 50,000 reviews by customer. Let's say you have a product on app store and 50,000 people have written reviews about it. And out of these 50,000 reviews, you just want to quickly find out, and you only have like a text of the review. Given these 50,000 reviews, you have to find out, say, whether the review is positive or negative. Okay. How are you going to do that? One quick answer would be that for each of 50,000, I'll ask ChatGPT to do it for you. But there'll be like 50,000 calls and it's going to cost a lot. So is there a better way to do it, right? So again, let me repeat. So you have 50,000 reviews. One way is that you create batches of it and ask ChatGPT a question saying, tell whether the following review is positive or negative. Reply only positive or negative. Okay. So, and let it, and this would answer, yes, this would, the ChatGPT would answer whether the review is negative or positive, but at the same time, it won't be able to, at the same time, it'll be fairly costly because you will have to call ChatGPT API 50,000 times. And this is where the idea, an alternate idea called the LLM embeddings or ChatGPT embeddings or language embedding or sentence embedding come into play. Okay, so that's why this particular session is extremely important because I want to introduce something called embedding. Okay, so and we will do the sentiment analysis. Given a review, we have to find out whether it's positive or negative. And this session is going to be extremely hands-on. So don't watch this session as, like a TV show watching comfortably. Instead, work with me in this session. It's going to be fairly hands-on. We will touch upon the basic maths from probably 8th grade or 9th grade and a bit of 10th, 11th grade. So we'll touch upon the maths. We'll touch upon the basics of programming. It's a programming and maths session. And I can guarantee that it'll be super easy for you. At any point of time, if you guys get confused about what I'm talking, please raise your hand, ask questions, and I'd love to clarify all of that. So this is something very personal to me. I wanted, because when I was interviewing people for product management, program management, even the various parts, I realized that everybody thinks that the large language model is only about replying to a question. And for many CXO level people, I have basically, like my friends who are at CXO level, I basically have given this example to them, have run them through this so that they understand the power of language and how do you utilize that power. And there's a bit of, carpentry involved. Okay, it's like, it's a like once somebody tamed a horse, people started building, these carts, for example, and other things. So similarly, after the LLMs or ChatGPT or large language models have come into place, now there are lots of engineering being done around them. So it's very important to understand a bit of mechanics of that engineering. And specifically, one of the less known fact is the embedding. That's why I wanted to do this. And I hope that all of you are motivated enough to focus on it. So be open, do not, I mean, this is not going to be very, very like a movie, right? It's not going to be easy to go because it would involve a bit of maths. You'll have to, keep going through the things, and you have to work with me instead of just watching. Okay, with that, let's move ahead. So my background, I have done engineering in my career a lot, machine learning engineering, and I've just started Mito basically into large language models, and it is doing very well, and I'm pretty optimistic and hopeful. And at CloudxLab, the core idea is that we should have, we have a playground whereby you have the you have the exercise notebook on the right-hand side and the question on the left-hand side, and it automatically checks whether you have done it or not. And this is extremely easy. Also, free-flowing lab is there. You can write your own code, whatever you wish to do, you can do at CloudxLab. Okay. And it provides you a real-world experience the way you will see it in industry. Then we have hiring partners, we have PET exams, and so on. Now, one important part to understand is what exactly is large language models. So I think that everybody is aware of by now. Now, moving ahead, with respect to ChatGPT, again, it's a big machine learning model, which learned by predicting the next word. And then it's predicting the next word for the answer of your question. Okay. So this is essentially what ChatGPT looks like, but there is more to ChatGPT than this, and it can do really wonderful job. It can do really wonderful job. And let me enable the, okay, let me enable the chat for everyone. Attendees can chat with host and panelist, and host and panelist can chat with everyone. Okay. All right. Let me see if there's a question. There's no question so far. Feel free to ask any question. And I would request everybody to pay attention. So how do you use or tame ChatGPT, right? One way of utilizing ChatGPT is large language model. I'm going to use large language model is nothing but an AI model which can generate a response text. Okay. So you give an input, or we call that prompt. It can generate a text response to you. But there is another way of using the LLM, and that is called sentence embedding. Sentence embedding is basically it takes the text, convert the sentence into bunch of numbers. Bunch of numbers means a list of numbers. Okay. And these numbers are like decimal numbers. Okay. So converting the language into its meaning, in some meaning, we don't understand that meaning, but we will utilize that meaning for our use cases. Okay. Now, so there are, first response is pretty simple, that you give the input, tell me, please read, let's say you say that correct the grammar in this sentence. Okay, so it'll correct the grammar. The other would be, so there are, when it comes to text response, this is something which everybody has learned pretty well, and people are learning those creative use cases. The use cases could be rephrasing a text. You can also ask it to generate SQL, right? Those who are not good with SQL, they can say, these are my tables having these columns, and this is my question. Like, give me summary, give me like average of the order shipped from my company. It'll basically generate SQL for the same, and you can run that SQL. And there is another very creative use case called mapping generation. Imagine that you have two database tables and you are migrating data from one to another. You can essentially ask ChatGPT, can you generate the mapping from here to there? Or let's say you want to build an autofill in the browser. You have the list of information about the person. So you can ask ChatGPT, these are the form fields available, and this is the data I have available. Can you map this to this? And you can use it for filling the form. Then translation. Translation is like convert this from Hindi to Chinese, Chinese to Hindi, and or English to Chinese, and something like that. So it can do the translation. Similarly, summarization, it can do content creation, it can do for you, and it can do a lot of things. The one thing that it should not do, and you should not use it to take the medical advice, okay? Because it can lie badly, and if even if you take that advice, don't take it seriously, okay? So there are lots of things that this is something that you can easily, you would be by now easily doing it, and using the ChatGPT or other large language. There are many other companies like Anthropic, Hugging Face, who are building, and even like Google, who are building their own large language model similar to what OpenAI ChatGPT does. So basically, these are the various use cases of ChatGPT or any large language model or BARD or so on. Okay. Now, the other way is by the way of converting the text into numbers. Okay. And that's called embeddings, text embeddings. Like you give it a text, say canines companions say. So this is the text that you're feeding the model, and it will generate bunch of numbers. This is a list. This is a list of numbers. Okay. We don't know what does this first number mean. We don't know what does this second number mean, and so on. Now, how big is this list? It depends upon which model are you using. There are quite a few models available in public, but but we are going to focus more on the most effective one, and the most effective OpenAI one gives a list of 1,500 number. 1500 numbers, okay, 1,519 or so. So I mean, there is no simple answer to how many, why 1,500. Okay, the way you look at it is, if this is a single number, it may not be able to represent all sorts of text, right? If therefore more the numbers, better it is. If there are too many numbers, it may not be much useful, because it'll be difficult to handle. Okay. So basically, converting text into bunch of numbers is called, these bunch of numbers is called embeddings, text embeddings. People call it, people call it word embedding, sentence embedding. There's too many names there, but we'll focus on text embeddings. Okay. These are, now question is that if I pass one word sentence, how many numbers will be there? Again, it'll be the same size. It'll be 1,500. I mean, in our example, it'll be 1,500. So no matter what's your text size, it'll be the same. Okay, moving ahead. So they kind of, basically these numbers kind of represent the meaning, and basically they represent sort of relationships. Okay, so things that are similar, they would come together. I will show you in more detail very soon, when we are going to do a bit of more hands-on, and it's going to essentially make sure that the things that are similar, they exist close by. Let me show you. Say for example, we have text like, how old are you? How old are you? What is your age? My phone is good. Okay. So let's say these are, and then fourth sentence is, your cell phone looks good. For each of these sentences, we found out the embedding here. Okay, we found out the embedding. And when we try to compute the distance between them, you will see that the things that are similar, like for example, my phone is good and your cell phone looks good, they are very close by. Okay, this one is, how old are you versus cell phone is great. But how old are you and what is your age, they are close by. Okay, because this sentence and this sentence is similar. So these numbers are close by. I'll show you more details about it. Okay, so this, again, this one represents the embedding distance. So we'll try to find out today in this session, how do you, okay, we'll try to find out how do you basically find the similarities between sentences using the embedding. Say here, let's say if somebody has to plot the similarities, using embedding, this is how it'll turn out to be. The most dark part means like they are exactly identical, right? A little lesser dark part, they're very similar. Very lighter means that they are not similar at all. For example, my phone is good and I like my phone. They are, you can see the darker color. Your cell phone is great and I like my phone. They are similar, but they are, you can see it here. So basically, using embeddings, you can find the similarity. Okay, you can find the similarity. How far is it and so on. Now, will it snow tomorrow and I like my phone is not at all similar. Therefore, it is lighter. So this is generated using the distance between embeddings. All right. And I'm going to go more into detail about how would you generate it, okay, today. And this is extremely important. Now, the other part is that once you have embeddings, right? So first way of utilizing a large language model was by the way of generating text. Second one was generating embedding. Now, what can you do with these embeddings? Okay, you can do machine learning around them by converting text into numbers and fit the models into it. The other way is by using the normal distance finding. You can build a semantic search. Semantic search means search that searches the text using the meaning. So you can, if you have, let's say, 50 paragraphs, and there is a question, and you have to find out which of these 50 paragraphs are similar to the question that is being answered. So you generate all the 50 paragraphs asked, and then you compare the embedding of these, embedding of the question. You compare the embedding of the question with each of the 50 paragraphs. So 50 comparisons. And then you'll be able to say that this one is the closest one. And that's how you build the search. Now, since it's going to be a bit slower this way, so what people usually do is they use a new kind of a database called vector database for the same thing. Okay, it does the same thing cleverly. Okay. And similarly, code search, similarly, building a chatbot, you can build your own knowledge article recommendation and so on. Okay. This, you see, zero shot classification, or you can say sentiment analysis. This is what we are going to do it today. Okay, the last one. All right. Also, as a announcement, we have a PG certificate course coming up, and the seats are filling in fast. So please enroll those who are interested to go deep dive into AI, generative AI, machine learning, and data engineering and data analysis. I would strongly recommend this course. So this course is basically a 12 months course. It's equivalent to, I mean, not technically, but from the perspective of the course coverage, it's equivalent to the masters, any masters. Okay. And it's basically one of the deepest and most significant course in industry. It starts from beginning and goes till, the generative AI. Those who are interested to go into this domain, those who are interested to become data scientists, data analyst, those who want to get into AI engineer, machine learning engineer, the course is for you. Okay. And even if you are already working as a data scientist, I can guarantee that you will learn a lot and you will enjoy this course a lot. So feel free to enroll in this course, and I'd love to have you in that course. So this is something very, very close to what I mean, to my heart, this particular course. And we continuously innovate in the course curriculum, probably in India or across. This would be the most detailed course on the subject, and it starts from the beginning, like understanding Python. All right. let's get started with the sentiment analysis with LLM. Okay. All right. Just give me a moment. I'll also check my, okay. All right. Okay. All right. Yeah. I'll basically take this repo. Okay. And this is the public repo. If you guys want, you can also clone it. Okay. Let me log in into my CloudxLab account. Yeah, CloudxLab, my lab. If you, let's say, log into CloudxLab and you click on my lab here, you'll be able to see the Jupyter link over there. Here, if you go to, say, Jupyter, yeah, please work with me in this class. So you can essentially, what you can do is you can open this particular file directly in your browser. Okay, if you are not having the CloudxLab subscription. So, okay. And yeah, start walking through this code line by line. And yeah, I want everybody to, just start going through this code along with me. Okay. This is extremely important. And this is something that will basically, as you walk out from this session, you will be able to appreciate that you learned something today. And yeah, that's why I'm insistent on working with me rather than just watching this webinar. Okay, so I'm just going to first open the notebook here. Okay, let me first open the terminal. Okay. Shubha, are you around?
Yeah.
So you have added the OpenAI key in this?
Yeah, I've added. I've also added the notebook. So if you sort it by last modified, you will be able to see it.
Okay, okay. Well, I don't have to clone it, right? Then
yeah,
I'll just remove this one, right? Okay, I'm just removing it. Okay. Again, let me sort it again. Okay, this one. All right. So this is the notebook, right? Okay. This notebook is available to everybody, so please feel free to walk through it as we, right? You can go to GitHub and take a look at this last file. And yeah. Perfect, perfect. So before jumping into embedding, right, let me briefly talk about something that you studied long back, the vectors. The vector is basically essential concept in maths, physics, and computer science. And all the three people look at vector in a different way. Okay. People in physics, they say that it has got a velocity and a direction, or you can say direction and magnitude, not velocity and direction. So in physics, vector is something that has got direction and magnitude. Okay. But for a mathematician, the vector is nothing but a list of numbers. It's a ordered list of numbers. Okay, or you can say few numbers that represent something. Okay, now the vector could be a vector could be 2 numbers, 3 numbers, 4 numbers, 5 numbers. Like for example, a vector containing what are those 2 numbers that will how many numbers will describe your position? 2 numbers in 2D world, 3 numbers in 3D world. And similarly, speed, velocity in like 3D space, whether you are going, I mean, if you're going in a space in 3D world, your velocity can be represented as 3 values, like um, the component in x-axis, component in y-axis, component in z-axis. Similarly, you could also represent it like with the 3 angles and the core velocity, but there will be 4 numbers in total. So there are many ways of representing same things, and mostly we represent things by list of numbers, or sometimes list of numbers. So either vectors or vector of vectors. Okay, like a shape is nothing but, let's say, triangle has got 3 corners, right? So each 3 corner are represented by 3 vectors, three tuples, which are 3 vectors, and then uh, and then all of these combined together make up a shape called a triangle that is a list of vectors. And that list of vectors is usually referred to as a matrix. Okay. So, yeah. So let's say, for example, the coordinate 2, 3 could be represented like this. But the easier way to draw a line from origin till here, and the easier way of drawing a line here. So this point is basically 2 on x-axis and 3 on y-axis. So 2, 3 is this line that you see. This is another way of saying that this is the vector in this direction. Okay. Now, vector embedding is nothing but converting these. The word embedding there used to be before text embedding came into play earlier, before say 2014, 15. It used to be word embedding mostly. Word embedding is you have word, you are converting the words into numbers, and you're plotting those numbers on the Cartesian coordinate system. And you're saying that, okay, there is a distance between king and queen and man and woman. And the interesting part was that if you do a subtraction of these vectors, you will reach to a very good place. Say, for example, king minus man plus woman would lead to queen. Okay. So that was another very interesting aspect about this. So similarly, if you convert walking into a word, into its vector, and walked into a vector, and swimming and swam into a vector, then you will see that the relationship between walking and walked will be similar to swimming and swam. Okay, so this was very quite useful. And in language understanding, the word embedding was a big breakthrough. When people did natural language processing, the word embedding was the biggest breakthrough of 2014-15. Okay. And then the large language models gave the best text embedding. Okay. So we are going to just jump into this. So I've kept my OpenAI key. If you want to generate your own OpenAI key, you can just go to the OpenAI key and sign up. They'll give you the key. Okay. So here I'm reading this file called OpenAI_key and saving that into this variable called OpenAI key. Though the name is identical, but this is a file name and this is a variable name. Okay. Now here I'm trying to show you that you can basically just call OpenAI like this. So here what we are trying to do, here, first the usual import. So I'm importing OS that is needed, and then I'm setting this environment variable that contains my key. The key I read from the file. Okay. So now here is the important part. Just like you will open this in browser, okay, you will open this in browser and set the various kinds of headers and other things, and you'll get an answer. This is what is happening, right? It's like filling a form. I'm saying that the input is equal to this product is good, and I want to use this model, okay? And then the OpenAI is giving me this return. You see that? Let me run it again. Okay. You did not provide an OpenAI key. Oh, you did not provide an OpenAI key. Let me try again. Ouch. Are you sure you put this OpenAI key?
Yeah, if you can, like, if you will check that home page only, like your Jupyter home directory,
Hmm.
you will be able to find it
For a
there.
moment, I'll pause my screen share. Okay. Oh, it's empty.
Oh, sorry, I'll add it. You can continue to the
Okay,
further.
okay, okay. Or you can just give it to me here. I'll put it. Okay. So I'm just, yeah, I'm just seeing my OpenAI key to be configured. So usually you have to go to their website and get the key and save it, and you can read it like this. Okay. Okay. All right. All right. So here essentially curl is a Unix command, or is a command to download any web page. Okay. If you have to automate downloading a URL, this curl will be the command to go to. Okay. And here what we are trying to do is, by the way of exclamation mark, if you run any command inside Jupyter, this is a Jupyter notebook. Jupyter notebook is a nicer version of prompt. Okay. If you go to Python and run it, it'll be like this. I'll just show you. Okay. So if you have to run something in Python, it'll look like this. Okay. You see this 2 plus 2, right? So this is my Python code. Okay. This is my Python code. So instead of using this terminal, right, we are using Jupyter. Jupyter internally uses that terminal kind of interface internally. We call that kernel. And it's basically about, yeah. Now, here,
I provided the OpenAI key in the Zoom chat for to you.
let me pause my screen. Otherwise, like if you guys start using my OpenAI key, then it will basically just utilize all my credits and I'll go bankrupt. Okay. All right. Okay. Let me test it out. Oh, it did not work. Let me try again. I am still keeping my screen paused. Okay. And let me try again. It says that we could not parse the JSON body of your request. This likely okay. Just give me a moment. Okay. Just give me a moment. I'm just trying to see OpenAI embedding. All right. Did it work for you?
Yeah, it was working for me.
Uh,
Again, there would be a change afterwards, so it was not working.
okay. Maybe they put in production or something new code.
Yeah.
Okay. So can you see if it's working for you now?
Okay, let me see just a minute.
Okay. Though, yeah, everyone, yeah, I'm just fixing these issues with the OpenAI key. Okay. Yeah, my previous OpenAI key, I deleted it because it became public. Okay. A question is, let me answer the questions in the meantime. One of the question is, how can I get the OpenAI key? You can actually go to their website. All right. You can sign up and enroll, and that'll be good. But if you are not interested in paying for embedding generation, there are quite a few free models. Like, let me see, open source models for text embeddings.
Sandeep, the
Okay.
key is working fine for me.
Interesting.
You can update it in the like file itself. So, and you can restart the kernel and try it again. I guess that may fix the issue.
Okay, let me. In your account or my account? Which one did you test?
In order to,
Just now you just tested in my account. Are you sure?
let me check again.
Do I have to remove the, there is a new line in the end.
Yeah, that may, okay, that may be causing the error.
But but you must have saved it like on that only, right?
Yeah,
Can you can you test in my account?
yeah, sure. Just give me a minute.
In the
Till then, you
in the
can
mean,
continue with the further notebook.
I'll I'll I'll, I'll answer the questions by then. Okay. 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 And okay, there is a question that I'm not able to continue the class for next hour. Can I get the recording? Okay, no worries. Yeah. And you guys are able to see the Q&A page, right? Where you can ask questions. Okay. And there we are. All right. A question from Praveen is, what's the difference between Google search engine and LLM embedded LLM model? See, Google search engine basically uses all kinds of things. Okay. One question is that does Google search uses LLM model? Not always. Google search engine was around the word search. Okay. So the way it was working is that Google will crawl everyone's website, index the data at their place. And if you have questions, it will basically find those keywords, find those websites that contain those keywords from its database, and then list it. So it was basically built around an idea called page search, page rank. Okay. PageRank was basically how many websites are linking to your website. That was the core idea. So it was not really searching on the meaning, it was searching on the keyword. Okay. While LLM model, it tries to answer a question in the natural language method. So LLM kind of tries to answer the question based on its mental model, and therefore it may not be able to give very factual information. You'll have to make sure that it gives you have to do fine tuning, a lot of other things in order to get the factual outcome from it. Okay, because it basically does approximations. Like, it basically tries to say next word. So there's a big difference between the way Google search engine was working and the way LLM model is. But as of now, the difference between the two is going down. If you see, Microsoft started using the ChatGPT to answer questions on the search. People are building the search engine based on the LLM embeddings now, and so on.
Sandeep, can you retry? Like it's working in another notebook. I can't open same notebook, but the code is working. So if you can restart the kernel and try again.
Okay. I'm restarting it. Okay. All right. Should I check out this thing again?
Yeah, you need to execute these cells. It was working fine in another notebook I tried in your account. So it should work here also.
Okay. Is there another notebook? Can I open that notebook instead?
No, I just tested this OpenAI key code because you are already open this notebook, so I can't open it. That's why.
Okay. No, you can open it. So, no, did you create another notebook? Can I use that
I
one?
updated the OpenAI key in the OpenAI key file itself. So now you can execute these cells and they will work.
Okay. I'm closing this notebook and we'll try opening it again.
Okay.
Okay. All right. Let's see. So this is the notebook. Okay. All right. This is where I'm reading the file. And it says you must provide a model parameter. Okay. All right. What happened to this? Okay.
I guess you updated the code. So if you can
Okay.
copy
Never
from
mind.
that only.
Okay. Let me
Not
see.
GitHub notebook.
Yeah, this one worked. So yeah. So here we are. So this was the actual original file, right? I kind of changed some of the lines. Basically, there is a spacing issue in the file. That's, I think, okay. So if I just revert back to, so it says you provided a model parameter. Looks okay. I think, yeah. Never mind. So here is that one on GitHub. Okay, this looks okay. This looks okay. Okay, let me see. F5. Okay. Oh, what happened here? Oh, I copied this curly bracket also. Yeah, perfect. All right, everyone. Yeah. A question from Shravani is that when one word is entered as text for embedding versus when a sentence is entered, is the number of embedding the same? Yes. That's the interesting part. And it's around 1500. Yeah. So this interesting part. So because that's interesting part because it kind of represents the intrinsic meaning, right? Whether you say a situation using a paragraph or you say the same situation using one sentence, right? The meaning would be the meaning could be same. And therefore, it's extremely important to keep the size of embedding to be same. So as part of the design, the size of the embedding should be same. Now, here you see these numbers. These numbers is what it has returned me. It returned that embedding. Okay. Now it's difficult to count it like this. Instead, we will use the code to do it. Okay. Now here is my Python code, and interestingly, the first version of this code we wrote it using the ChatGPT itself. We asked ChatGPT, can you Can you write code to generate embedding using OpenAI API, and it generated well. Okay. So here is a code. Okay, those who are interested in the code, I'll just explain. These are the various packages in every programming languages. Since the work could be involving many things, therefore there are packages. People create the separate packages. So NumPy is for doing numeric computing. This is for accessing the websites. This is for handling the data format called JSON, JavaScript Object Notation. You don't have to memorize any of this. This is just to make you comfortable with the idea that this is nothing but importing external libraries, right? Then we are saying that this is going to be the URL which will give us the embedding. This URL is from OpenAI as per their documentation. Then we are defining a function which will take a prompt, okay, which will take a prompt and it will return the embeddings. Okay, it will talk to their URL, provide all the header information, all the data that it requires, and then it will return the embeddings. Let's take a look. So we are saying embedding is equal to get OpenAI underscore embedding, and how are you? So we are saying that we are calling this function we just defined. We are giving a sentence called how are you? And it is converting it into bunch of numbers. Okay, bunch of numbers. Now, how big are these numbers? Let's take a look. So when I say embedding dot shape, it says that it is 1536 numbers. Now let me try doing it again. Okay, let me try doing it again. Let's say, okay, I wanted to ask you if how are you doing? Okay, so this sentence and this sentence, okay, though the size of the sentence is different, it is still 1500. Okay, now if I just pass an empty string, if I pass an empty string, okay, the size of that one is also 1500, right? You can see that. So no matter what, like even for empty string, you see there are numbers, right? So empty string itself has a lot of meaning in it, and that's why there are embeddings, valid embeddings even for empty string. Okay, all right. So we had written some code to visualize these embeddings. So I'm going to walk you through. You can skip this part. Those who are interested, they can look up PCA. So it's basically converting 1500 dimensions into 2 dimensions. Okay, so we will use this mathematical idea to convert this embedding from 1536 to 2 dimension and try to plot it, because we can't plot it in more than 3D. Okay, we can't visualize even in 3D, it becomes difficult. Therefore we will try to visualize it in the 2D. Okay, let's take a look. So what we are doing here is we are visualizing cat, dog, bike, kitten, puppy, bicycle, aeroplane, cow, wolf, and then let's take a look. Okay, so here Now, here, we are visualizing their embeddings. Okay. All these 1500 numbers we converted into by putting like the way you take a photo and you reduce the dimension. We kept on reducing the dimensions using an algorithm. Now we are plotting that on 2D. You see that? So cow, wolf, cat, dog, and lion are very close by, while bike, bicycle are close by, helicopter, fighter jet, aeroplane are close by, and kitten and puppy are close by. You see that? Now that's an amazing power of you know, embeddings. So embeddings, even though they look like bunch of random numbers, internally they have a meaning. When you plot them, it turns out that those numbers, if the things are similar, they end up close by. Okay. Anybody wants to add any word? Yeah. I'll try to plot it again. Yeah. Suggest me some word in chat. After that, I'll answer the questions. Tiger. Okay. Let me put tiger. I'll put tiger extra. Okay. I will put tiger. Okay. Apple. Lion we have already put, right? No. Lion is already there. Shivam. Oh, you want it in caps, is it? Okay, let me put in caps. Apple. Yes. So the interesting part here, a question from Shavni is that, but uh, dog and puppy and kitten and cat are supposed to be close by. Okay. But if you tilt this plane from that, see from this side, they will be close by. Okay. So let's try to do some more thing. Let's try to add cub. Okay. Cub. Okay. Right. And then you'll get an idea. Is it working? Or is it plotting? Now you can see everyone. So essentially, this area somewhere, basically, since we are projecting it into 2D, what is happening is things will get a little messy. Okay. And and that's the reason why there have to be more and more dimensions. Imagine plotting this on 1D. All of these things will come together, right? Apple, bike, everything will be here, right? That's why more dimensions are needed to represent the complex relationship between things. And as you increase more and more dimensions, it would get better. Okay. So you can always see one very important aspect is that, right? The distance between tiger and cub will be smaller than tiger and apple. Okay. And to find the distance is something that I want to spend the rest of the time. Okay. I hope you guys are able to see this visualization. This distance confusion is basically, it's a very, very interesting question. And I wanted more people to doubt this. Okay. That how come tiger and kitten are not close by? It's essentially, if you look at it from at the other dimension, most likely that they are far away in the space. And I mean, bicycle and this is way, way far away in the space and so on, right? This whole data is in 1500, how many dimensions? Okay. So 1536, okay? 1536 dimensions, okay? I cannot visualize more than 3 dimensions. I'm not sure you guys can, I'm not sure how many of you understood Interstellar. I never understood Interstellar because it talks about more dimensions than 3 dimensions. And as a matter of fact, we are not capable to visualize. I said visualize. Okay. And there are like visualizing is hard, anything beyond what we have seen. Okay. Some like my kid was asking me a couple of days ago, can you visualize a color that does not exist? And I can't. And that's a very valid question. In the same way, can you visualize any dimension beyond 3D? I can't. The only thing I can think of is, oh, it's a bunch of numbers and I can put it like this and it'll be like that. So now let's do a bit of more journey towards multidimensional part. And this is where things get a little more interesting. Things, things get a little more interesting. And okay. A question from Shaksham is that how does the embedding algorithm work, taking the negative and positive numbers? Okay, so the way embeddings are usually generated is the same model, like LLM model. Remember the LLM model, where we feed the text and it gives out the next word. Okay, and there are a bunch of numbers getting translated. So what they have done in embedding is that they have taken the numbers in the last layer of the neural network, and that is what they're calling it, the embeddings. Okay, of course there's a little more complexities involved, but I'll talk about probably later part of time. So the embedding algorithm works by uh, taking the works by utilizing the neural network. And I mean that's the thing. Okay, because they realize that the large language model, when it takes your input, a text, it tries to bring it close and so on. Okay, do you guys want to test this on paragraphs or sentences? I can test that for you. Okay. Okay, let's try to do it. Let's say first is, okay, the world is, or give me good sentences, 10 sentences, okay? Yeah. Oh, yeah. Or five, a couple of words, let's say 10 phrases. I will test out the 10 phrases, okay? Okay, first one I got, kittens and dogs are running the, okay. Okay, did I remove anything? Yeah, I removed the cat. I'll keep the cat as well. Okay, let's see how it goes. Okay, anybody else wants to give me some more sentences? International space stations are awesome. Okay, and I'll say that it is an awesome experience to visit an international space station, a space station. Okay. Okay. And okay, give me something which is having multiple meanings, and let's see how it goes. The let's say thinking outside the box. Okay. Okay. Creativity box. Okay. So I'm just trying to show you that it should ideally, you know, be able to plot things. You can see here, thinking outside the box is closer to creativity than the box. You see that? Thinking outside the box is very closer to creativity as compared to box. And that's the power of LLM. Okay. If it was just doing the word count, it'll say, oh, this is here. And International Space Station are awesome, and it is an awesome experience to visit and station space. It's very close by, right? And so on. So I think the LLMs or the embeddings actually represents the meaning of the sentence. Okay. And you should do more experiments in with this notebook. Okay. So in your free time, you must explore the okay. Okay. I got quite a few things. Okay. Okay. I think you guys should try it out. Okay. I got some of them. I think you guys should. I want you guys to try it out. There are very interesting chat messages that are there. I'll put it for everyone. Okay. Okay. All right. You guys should try it out at your own time. I'll move on with the rest of the discussion. Okay. I'm copy pasting it in the chat. So you guys should try it out. Perfect. All right. All right. Moving on. Now, a bit of, let me take you to your childhood journey. Okay. How many of you know how to find this hypotenuse? You have this side is 3, this side is 4. How would you find out that this one? B and C? Quickly. How do you find that this distance, the distance between this and this? Right? Using Pythagoras theorem, square of this distance is square of this distance, you add up together. Correct? Okay. And yes. Okay. Pretty simple. Okay. We can just do C square plus A square and so on. Right? Now, you are given two coordinates, 1, comma 2 and 4, comma 6. What's the distance between them? 1, comma 2, x is 1, y is 2. For the second point, x is 4 and y is 6. How much is the distance between these 2 points? Between point 1 this, and point 2. So this is 1, comma 2, and this is 4, comma 6. These are 4 studs, and this is 6 studs. Okay. 6 units, 4 units. So between this blue and red point, what's the distance? Everyone? Okay. Let me also. It's a workshop. So everybody, you work with me instead of just watching one day. In the meantime, I'm connecting them. Okay. I'm joining. Okay.
Recording in progress.
So that I can quickly draw, I'll just use my iPad. Okay. All right. So the distance from here to here, how much is this distance, everyone? That's right. This distance is 3, 4 minus 1. And this distance is 6 minus 4 is 6 minus 2 is 4. No, 4 minus 1 is 3 and 4. So, and this is going to be 3 square plus 4 square, right? The square root of 10. Okay. So I hope everybody is clear about it. Right? And that's it. Okay. Now moving on to the 3D space. Okay. Moving on. So it's pretty simple. What we can do is point to, this is how I'll write the code. If you have 0.1, 0.2, I'll say 0.20. That means access 0.2 is a pair. Okay. Let me show you what is 0.2. If 0.2 and 0.1, I'm just printing them. So, okay, let me start from here. Okay. All right. So it's pretty straightforward. So basically, these are 2 points. Now, finding the distance between them. So 0.20, which means this 4, 0.10, this is 1. So this is basically 3. So we subtracted x coordinate and y coordinate, squared them, and then we did the square root. Okay. The easier way of doing the square root is using math.square root. Okay. So you see the distance between them is 5. So this is your Python code to do the Pythagoras in 2D. Okay. I hope everybody is clear about what's going on here. Yeah. Now, this is also called a Euclidean space. So if you have x1, y1, x2, y2, what we do is we use this formula called square root of x2 minus x1 square plus y2 minus. Now, we can extend the same theorem, same Pythagoras theorem to 3D world. Okay, you have, let's say, this is one point, this is another point. When you project it on the 2D, right? So we have to basically use 2 triangles. Okay. First, using this triangle, okay, we find the D. D is the base for this triangle. So we find E. So if we have to find E, first we find D and then we find D. Okay. So how much is D? D is going to be square root of A square plus B square, right? And then E is going to be square of D square, which is A square plus B square, plus C square. So this is going to be A square plus B square plus C square, right? So to find the distance, what we have to understand is we basically square each of the differences in axes. Okay. In 3 dimension, what do? We compute these distances. Okay. We compute the squares of the differences, sum of the squares of the differences, and then the square root. Okay, so pretty simple, this one. So if our points were point 1 was 1, 2, 3, second point was 4, 6, 8, right? The way I'll calculate the distance is by the way of using this differences. Okay, so I'll say okay. Now here, right? So the delta x, delta y, delta z, we calculated by subtracting, and then we squared them and did the square root. To the power 0.5 means doing the square root. Okay, and that's about it. Pretty simple. So here is our point. Now, if something was 4 dimensions, we will be doing basically there will be 4 values underneath. Here there are 6 xyz. If their fourth one will have, let's say, u representing the 4th dimension. Okay, and essentially that's about it. So we can find the Euclidean distance or Pythagorean distance or L2 distance. There are many names to it by just saying x1, x2 subtract, y2, y1 subtract, and so on. And then we keep on doing all of them and then do the square and the sum it, do the square root. Okay. Now, let's say we got the embedding for cat. Now let's do it in 1500 dimensions. Okay. And yeah. All right. Yeah, there is a question from Srikanth. Okay. Now, okay. So basically, we are using the embedding here. We are calculating the calculating the embedding of cat, putting it in a variable called cat. Here, this is a text because it is inside the single quotes. This is a variable. So this is going to be an embedding, another embedding, another embedding, another embedding, right? So then we are saying calculate distance. Remember the formula that we derived here? Calculate distance. What it does is it goes over all the axes of point 1, point 2. Okay, right? This is it's not xy, it's basically point 1 and point 2's p1, p2 value. Okay, for each axis. For each axis, they are doing that. Let's say I'll call it p1 and p2 just for simplicity so that you don't get confused into thinking that we are doing it in two dimensions. Okay, so here, okay, so you can basically use that formula to compute the distances, right? So this one seems to do well here. We did calculate the distances. So here we are doing the distances between point 1 and point 2. Point 1 and point 2 are in how many dimensions? 6 dimensions. Okay. So it works well. This formula is working well. We are going over point 1, point 2. We are zipping it. I mean, I would say that, right, if I have to make it more simpler, like because many people would be here who are very new to Python. So what I'll do is, right, I will say for I in, let's say, for I in range length of 0.1, right? So what I'm doing is going over the length of 0.1, right? Then what I'm doing is, this is my distance, okay? Total distance square, okay? So let's say this is 0 initially, and then I'm just trying to simplify it so that everybody understands it. So I'm adding to this one, okay? I'm adding to this one what? Okay. So I'm saying the value of 0.1 is 0.1 I and okay, P2. The 0.2's value for, I'm iterating over all the axes, 0, 1, 2, 3, like that. And this one. And then what I'm doing is I am doing the square. Okay. The way you do the power is by doing 2 asterisks in Python. Okay. I'm doing it because I think that not everybody is comfortable with Python very much. Okay. then I'm returning the distance. Okay, let's see. Okay, is my code working well? Yes, it is working well. All right, so calculate distance. This is the one that I have written. I hope everybody is okay with this piece of code. I'm going over the length of points, 0, 1, 2, up to that length, and then extracting each excess, subtracting it with the corresponding between the two of point 1, point 2, and then squaring it, and then summing it with this one. This plus equals to mean I'm saying distance and the score square. So I'm adding up distance with itself, and that's what is going on. Okay, so that's about it. And yeah, now it's a time to compute the distances, right? Okay, so you can see the distance between cat and dog is 0.52, cat and car is 0.56. So definitely cat and dog is closer to cat and car. Car is farther than cat. Uh, as compared to dog is, right? Cat and bike, cat and bike, it is um, even farther, okay? And yeah, you can't compare these two, saying that, oh, cat and car are only 0.56, cat and bike is so much. So it's difficult to justify that part, but never mind. So bike and car are closer to bike and cat. Okay, if you see that. Bike and dog, bike and dog are is this much 0.57, and so you can see there is there is you know definitely a relationship here. Okay, so the distance actually represents something. Okay, so the distance, the one that we used our formula to convert cat into a number, the distance between cat and dog into a number, that is seems to be useful. Okay, now comes utility part of this knowledge. Can I use it? Where can I use it? Now let's go back to the question that we started with. Can we do the sentiment analysis using this technique? Okay, so what we are going to do is we are going to use this in order to figure out whether a particular review is positive or negative. Okay, so imagine that you have a sentence saying the product image is amazing. Okay, the product image is amazing. Sorry, product is amazing. Okay, let's say this is one review. The other review is product is not good. What we're going to do is we take each review, find the distance from positive and negative, and then say whether it's a negative review or not. Okay, sounds very hacky solution, but it actually works. So this is called zero shot sentiment analysis using LLM. So what we are doing is that we found the okay, we yeah, here we found the embedding of both all the four things, okay, and plotted it. Now you can see the product is not good, the product is amazing, negative and positive. Which distance seems to be closer, this one or this one? A or B? Which one is closer? A, right? That means that if we find the distance between this point and this point and this point, we can easily say whether something is a negative review or positive review, right? Similarly here, you can see. So this distance and this distance, right? Which one is easier? Which one is closer, C or D? Okay. So that means it is a positive review, correct? So now let me move ahead here. Let's calculate the distance between the good review and positive and this one. So, okay, where did we define these? This one. Okay. All right. Now we can have this thing as a logic in the code. Okay. So first, whatever is the review, we will get its embedding. We got the embedding of the review. Then we calculated the distance between this embedding and the embedding of the word positive, which we calculated previously here. The embedding of positive word, embedding of negative word. So now we are computing the distance between the review and the word positive. Then we are computing the distance between the review and the word positive. If the distance from positive is lesser than the negative, then it is a positive review. And we are printing it, and as well as we are returning this. Okay. So, and then we are saying, otherwise we are printing negative review. Correct? Does this function make sense to you? Pretty simple, right? So we calculated the whatever review you give, this function will print whether it's a positive review or negative review, and also return it so that you can use it elsewhere as well. Okay. Now, so, okay. Now here, the here is the review. Camera quality is too worst. Don't buy this if you want good photos. We can get this quality picture with 5,000 rupees Android phone. I am totally disappointed because I expected range of iPhone camera quality, but not this. Waste of money. Okay, so this is a negative review. Okay, so, okay. I hope it makes sense to all of you. Okay, any questions? I would love to answer your questions. Yeah, feel free to ask. Was it helpful for all? No? Though there are lots of further ideas around it. Okay, lots of further ideas around it. I want you guys to I mean, this is more than sufficient. I would not get into more details right now. Okay, but the code is there in this notebook. Feel free to use it. And even the other part, I wanted to talk about the dot product between two vectors. Should I talk about dot product between two vectors? Are you guys up for it? Okay. I got only one word. Okay. Two words. Okay. All right. Okay. A question from Saksham is that can two different but similar sentences or phrases have same embedded encoding? Okay. Question is, can two different but similar sentences or phrases have? No, actually, the embedding will be different. You can actually try plotting it, okay, very similar sentences will be very close by, very different sentences, even if the same word is there. Okay. And let's talk about some word which has syntactically similar, but meaning wise they are very different. Like let's talk about two sentences. The way I gave you the idea here that the okay. For example, let me show you again. Let me go back here. See here, creativity and thinking outside the box are two different words. Okay. And you can essentially experiment here. So yeah. Also keep in mind that embeddings won't be similar. Okay. Won't be similar. Instead, the distance will be too small. Okay. So pay that attention. So the distance would be smaller. Okay. So embeddings, of course, will look similar, but they won't be like, okay, all of these numbers are same. First 1,000 are exactly same numbers, and then 500 are a little bit different. No, the values will be, close by, but not same. Okay, so that's why we always measure the distance, not the anything else. And these models are designed such that the distance is close by. Okay, now let's say, okay, let's say I'm removing these two. Okay. Okay. I said thinking outside the box. Okay. I'll remove this. Okay. Uh, Sitting outside of the box. Okay. Let's see how it looks. Okay, they look like very, yeah, interesting. Now, how do I find the exact difference between this? Okay, we can do this, compare the distance, right? Here. Okay. Never mind. So I think you got the idea. So I mean, try experimenting with the phrases, and you'll get your answers. Okay, and try computing the distances. Take it as a homework. Take it as a homework, and use this creativity to do hands-on. Use this curiosity that you have as your motivation to do hands-on, and do the hands-on. My request to everybody is give it a shot. Give it a shot. All you need to do is just get some API of OpenAI and start experimenting there. Okay, so that will be my request to everyone. And okay, very good question. A question from Edward is that how would you what are your ideas to support neutral review? Correct. So there are two ways to do it. One is you can define threshold, that if the difference between positive and negative distances is this much, then is lesser than this much, then it is most likely a neutral review. That is one idea. The other idea is you can have a third keyword like positive, negative, and neutral, and compare the distances. Okay, those are two ideas. A better version of this is that you can, if you have to, let's say now do the other things. Imagine that you have to build a model. You have to build a model which can give precise ratings. Okay, so what you can do is take all the reviews from Amazon. There is a database of reviews provided by Amazon along with the ratings. convert all these reviews into embedding. You got a bunch of numbers as the representing reviews, and you got, let's say, ratings. Now train a model which will take the embeddings as input and predict the learn to predict the ratings. Okay, that would be my third idea. Okay, but there are quite a few ideas in this game, and I would say that be creative, utilize these embeddings in your game. All right, will same sentence have same embedding values always? Very good question. Very good question. The answer is, earlier, since LLMs have a tendency of randomness, so there were chances earlier, but now, I mean, unless and until the model changes or you are using different models, the embeddings are usually same. Okay, I mean, even earlier embeddings are usually same. This is what I've noticed, unless in the backend they upgrade the model. Okay, the moment you retrain a model, you do a bit of fine tuning or changing the model, that it will give the different results. Okay, though the same, there is something called temperature and other things, that's a different thing. Okay, and I can talk about that particularly later, that LLMs can give different outputs every time if you set the temperature or let it do a bit of serendipity. But in case of embedding, the answers were, I've seen it to be same. Okay, now going back to, okay, all right. A question. So it is not just semantics, but contextual. Yes. Thank you, Shravani. Yes. Okay. Yeah. Everyone, check out our upcoming course. I would love to have you in my course. I want you to, go through it in deep dive manner. The other very interesting measure. So one of the distance, in how many ways you can find similarity between these two words. Okay, this and this. Okay, one of the ideas that has been is the, let's say this is one word and this is another word. Okay, so how would you find this distance? Okay, how do you find the measure of distance? One of the measure distance is, you call it L2. Okay, Cartesian also, we call that Cartesian, and there are multiple words to represent it. Okay, so this one is L2 distance, like we did what we just did. Anything else? The other interesting measure is called cosine distance. Cosine distance. Okay, if you can find the angle between them, then it'll be great. But question is that even if things are far away, the angle would be lesser. Okay, like for example, positive and negative word, the angle seems to be very small, isn't it? Now here's the interesting bit about it. Okay, here's a very interesting bit about it. Okay, very interesting bit about it. So if, let's say, 2 points are on a circle, this is me and this is you. Okay, right? Now if you measure this angle between me and you, or you find this distance, it's going to be same, right? So basically, either you compare this angle or you compare this distance, right? So it is same. if things are on a circle, if things are on a circle, the distance, either you use the L2 distance using the Pythagoras, or you find the angle, both will represent the similar thing. Using both, either the angle or the distance, you can say confidently, right? This one you learned how to do this, right? This distance, a minus b square plus b minus c square and all that. But how do you do this? Now, here's a very interesting part. The embeddings generated by most of the model lie on a circle. Okay, you don't believe me? Let me show you. Let me show you. This is a very interesting part. So the embeddings are, what is the definition of a circle? X square plus y square. And if it's it's a sphere, z square is going to be 1. It's on unit circle. Okay. So I'll show you unit sphere or circle. So let me show you if this is true. Okay. Where are we? Here. So if you take a look at it, I'm saying embedding positive multiplied by embedding positive. Okay. It's going to basically multiply all the values with itself. Okay. Right. And it turns out to be almost 1. Similarly, this is another embedding that we have. So every embedding has this nature, which basically, I mean, this is part of how embeddings are constructed. So these embeddings, though they look like random numbers, but they all lie on some sort of a hypersphere, a sphere in 1529 dimensions. Got it? So since they are on a sphere, now we can find the angle between them. How do you find the angle between them? Anybody? How do you find the angle between 2 points? Okay, this angle. This is x1, y1, x2, y2. Yes. Yes. So these embeddings lie on a sphere of 1529 dimensions. Okay. So what do? You usually use this, remember cosine of a minus b? Remember cosine of a minus b? This is a minus b. Okay. These are two triangles. Okay. It is cos a, cos b plus sine a, sine b. Okay. Remember this, no? Cos theta is equal to a minus b. Okay. When you expand it, you will find that cosine of this theta is, when you expand it and try to solve it, it turns out that it is x1 into x2 plus y1 into y2 divided by x1. Sorry. Okay. When you solve it, remember that the definition that we used to have, right? X1 divided by, okay. This looks crazy, but if you remember your time. So this is essentially sine B, sine A, cos B, cos A, right? And this, we know that this is 1, this is 1, this is 1, this is 1. So, right? We just said, So the cosine of angle will going to be x1, x2 plus y1, y2, right? Correct? So if this turn out to be 0, correct? That means angle is 90, right? Angle is 90. That means it is very dissimilar, okay? And if this turn out to be 1, that means angle is 0. That means similar. So pretty simple. All you need to do is multiply x1 with x2, y1 with y2. If this turn out to be more, that means it's more similar. If it turns out to be less, it means less similar. So all you need to do is, this is called dot product. Okay. So you can basically whatever we did just now using the Pythagoras theorem, you could also do a dot product. Okay. It's a pretty simple thing. So even if you did not understand the maths, the one that I described just now, you can simply either use the L2 distance, or you can just do a dot product between the two vectors, and that should do a good job. So you can do the dot product like this, let's say the embedding that we are computing, this and this. So we computed the dot product. Dot product represents similarity. If positive is more than the negative, that means it's a positive review. Otherwise, it's a negative review. Remember earlier, this sign was less than. That was for distance. Here, dot product is basically a1 in x1 into x2, y1 into y2, like that for all 15 dimensions. So this dot product will multiply 15 numbers to the corresponding 15 numbers, and then it will sum up all of that, will give you the distance. So you can see here, this is a Hindi version of this product is good, okay? And it has figured out that it's a positive review. And this again is a Hindi version of this product is bad, and it turns out that it's a negative review. Okay, so essentially the only difference between the previous approach is the metrics that we are using for distance. Earlier we were using L2, the Cartesian distance. Now we are using a dot product. Dot product is based on the cosine similarity, right? Cosine similarity is nothing but finding the angle between the two vectors, and that is done using the dot product. Okay, I hope this was useful to all of you, and right, this is one of the rare sessions where I have used maths, because I was told again and again that people do not like maths, so don't show maths in the class. But I feel that it's okay. Even if one person is benefited from the class, my webinar is successful. So I'm very happy that, thank you, Saksham, for the great comment. All I loved about the session is using mathematics during the complete session, and awesome explanation. And there is a question from Edward. Question is, how good are LLMs at different word spelling, say British spelling versus American spelling? Good question. Good question. I would request you to give it a shot. Okay. I would request you to give it a shot. It is pretty good at both. It can actually, it understands the difference between American spelling and so on. You can actually say that, can you translate these sentences from British to American? And this is pretty good. Okay, so just experiment. My request will be explained. A question is, will we be able to access the recorded web video afterwards? Yes, it'll be available on our YouTube channel. And feel free to share about the webinar with your friends, and also feel free to reach out to us. I love to have all of you in my class, and we are running 5 minutes over time, but I think it was worth all of your time. Thank you, everyone, and I hope the simple ideas about the geometry that we studied earlier in childhood is pretty simple. And a question from Saksham is, can two different but similar, yes, that's right. Can you share some papers that we refer to read more? Sure, sure. We'll share it on our blog post and we'll let you know. Okay, wonderful. Thank you, Srikant, and I'm happy to have all of you. I'm really thankful to my team, especially Shubh, who has arranged everything for this. And again, thank you everyone for coming, and I would love to have you guys in my session. Okay, have a good day. Thank you, everyone. All right, bye-bye. Have a good day.